Yeah. One more thing I want to show. I'm not going to say. The thing about the
Hello, y'all.
Kasi kami di kakra.
Okay. So take your time.
Maybe kra.
Okay. Yeah. My sister computer no, but my name say software no, so still a little bit slow, but I think so we can still work. Just right, we'll try and share that map up. But maybe I may share screens this year. It's now we're then. Go baby and
Ako baby mo Windows
yeah. Yeah, let me try my grass. This year, and maybe.
the weeding.
Mowing. Let me see machine. Yeah. Yeah, kakra wa kyerɛ sɛ meyɛ. I think. Yeah, na ho yɛ ne wahu no.
Baby o. Ɛno ani ni nyame ntɛ no.
Saa.
Na me friend na so mafa.
Na mo sɛ ne 99 no. Te sɛn.
Say yes, nti me sure so okwa yi. Last one to from us. Tete mu obi a da kɔta no fi. Nti da kɔ office yo kɔta no fi. So mana pa anan ni. Yo ka so okwa yi.
Okay.
But I'm not going to maintain film. I said, okay, so.
Okay. All right, me share my screen as a one. All right, you've been on class. It's time to figure out what's going on. Okay, yeah, let's see if we can just manage this. Okay. Into this, how many? 1, 2, 3, 4, 5, 6, 7. It is 7 properties in a person kayak. Yeah, briefly, the cover before we continue, with the meat of what we want to learn. But these are, fundamental. These are the basic stuff that we need to know. The basic things that we need to know. Okay. So the first property, commutative, is a kind of almost too many times. System failure, computer problem. Okay. So commutative, basically you have commute. So it's movement, right? So moving from one place to another. So we are looking at the expression. So you can have mathematical expression. Okay, so I can't write.
What's your amount?
I try. Some more. But okay, so it's the tablet. The tablet run is the tablet. My first setting. It's going on. Okay, so maybe we'll work this time. Okay, so communicate. So basically, when you have a mathematical expression, so mathematical expression, you have, let's say, you have euro technology. Okay, we're fine to say, try about that. Well, no idea. Okay, so A class. Wow.
Now be take it time now ahead you na.
Because it do in so. I mean, I'm friend yeah, I will just a bit journey at was next time. Remember, I mean, try something. One last way. working. Very annoying. Yeah, intention. Yeah, we need time. Dum so. This time I want your life. So, this problem they mean baby to try come out solve that. It's just going to study. Okay, I mean, changing mode. I mean, sure. One. All right. Yeah, this will work. It's not the best, but I think it should be okay. Remember, I say to communicate, example, if I say, oh, number bit is let's say x plus 5. So x plus 5, where this is a mathematical expression. The x plus 5, you can rewrite it as 5 plus x. So you can rewrite it as 5 plus x. If that helps you to solve the problem, if that helps you, you can write it as 5 plus x, and they are equal. Okay, so or if it is multiplication, you can have 5 times x. So 5 times x, you can rewrite it as x times 5. You see the same thing. So or you can use minus. Well, anyway, or minus will be different. So this one, just what you see minus a better wrong. 5 minus x is not the same as x minus 5. So yes, yeah. And now you can use multiplication. You can use division, because x divided by 5 is not the same as 5 divided by x. So, but 5 times x is the same as x times 5. X plus 5 is the same as 5 plus x. It's going in here, then your friend a commutative. So, which amount? Which mean a question be? Which mean a question be say? Which mean a question be say? This is the math calculation. 8 x is equal to x8. So, no, which I said, this is true, okay? This is true. And why is this true? So the reason that this is true is because according to the property, 8x can also be written as x8. Thought I said, which means a question with the 10 plus y is equal to y plus 10. So that's a y. Why is it true? And this is true because of the commutative property. Okay, yeah, that is all you need to know. Now, actually, as for the term, the concept, just so you can talk about it. But really, all you need to know is that anytime you're solving some math problem, you can rewrite the expression in a different way. Rearrange them. If what you are working with, if the operations you are working with are multiplication or addition. Okay, if it is multiplication or addition, you can rewrite them in this form, and it should not affect the solution. It should not affect the final answer that you will get. Okay, so what you say. Now, so that's for commutative. Next one, associative. Now, associative means basically when you hear associative, think about grouping. Associative, writing in papa. Think about grouping. Grouping. Well, me use pen, no. Me use as penna instead of my papa, and me use as mouse until I write and instead of your fine. Okay. Associative. When you can have associative, anytime you hear associative, think about grouping. Well, you associate. Okay. Okay, so and in that too we have addition. So what mainly is addition. Let me check it actually. All right. Yeah, so association, we have addition and multiplication. So if you have, like what I have there, A plus parenthesis B plus C close parenthesis. If you have something like this, you can rewrite it as A plus B plus C. Now, basically, all we are doing is we are reassociating the variables. Okay. Now, this is possible because we are dealing with addition. This is, the important thing to note is the sign. We are dealing with addition. So the same thing with commutative. It's possible if you're dealing with plus or multiplication. So this is equal. So these two expressions are equal. The same way, if you take multiplication, so A parenthesis B and C, which is A times into bracket, or actually this parenthesis B times C is equal to, we can regroup them to be AB inside the parenthesis times C. Okay, so this is the same thing. And these are equal because because of the associative property. The associative says that if you're doing addition or multiplication, you can regroup the variables. You can move them, basically you're using the parentheses. So the parentheses is the tool that we use to group. We're using this to group. Okay, this is the grouping tool. This is the grouping tool. So you can use this tool to regroup the variables. And this is true in every case that involves, addition or multiplication. Okay, so that is associative. It's grouping. You're grouping them. Commutative is moving. You're moving them. Next one is additive identity. And that one you already know, we won't waste time on it. If you add any number, but if you add 0 to any number, the end result is the number itself, right? So let me ask you a question. If you look down here, a plus 0 is equal to 0 plus a. What property is this expressing?
It's commutative property.
Yeah, so it's commutative. So expressing commutative property. And then because of the additive identity property, the answer that we get is a. So a plus 0 is the same as a. All right, so that is that. The next one, additive inverse. So additive inverse, also we know that one. Any number added to a negative of that same number. Hang on, my mistake. Okay, no. So if you add any number, so the same thing. This is the first expression. 12 minus a plus a is equal to this expression. So here, commutative. And then the answer is 0. So we know this is 0 because of the additive inverse. Basically, you're adding the opposite. Okay, so that is the additive inverse. Now, multiplicative identity. Multiplying a number by 1 is the number itself. Okay, so if you look here, so it's now you can see that commutative, and it's not by accident that usually it is mentioned first, because it runs through, it's very basic, or kind of any math expression, because all the other properties that we have talked about, you can see that the variables are moved around, right? So a times 1, and then that's equal to 1 times a from the commutative, and the answer is a, the number itself, due to multiplicative identity. Multiplicative inverse. Basically, any number, take the number, multiply by 1 over that number. Okay, that's the inverse. So if you take the number 10, the inverse of this number is 1 over 10. I don't know the symbol for inverse. So inverse is 1 over 10. So when you multiply any number by its inverse, you get 1. So multiply 10 times its inverse, 1 over 10. What will happen is 10 will cancel out 10. So you end up with 1. So the inverse of any number multiplied by that number is 1. So that's what we are doing here. A times 1 over a. So 1 over a is the inverse. It's equal to 1 over a times a, which is the using commutative property, and the answer is 1. And here we are saying that if you know that, even though I said any number multiplied by its inverse, there is a catch, there is a caveat, and the caveat is that the number should not be 0. This is because, let's say you have the number 0. Okay, so from the way I explained it, I said the inverse. So in this case, the inverse of 0 will be what? What will be the inverse of 0 in this case?
1 over 0.
Yes. So 1 over 0. Okay. But this is mathematically not correct. Impossible, because you cannot divide any number by 0. You cannot divide by 0. There is no solution. That's why they are saying that. That's why they are saying the number should not be 0. So 0 is the exception here. 0 is the exception. Okay, so that is the inverse. And then the last one, distributive property. Distributive property. Now distribute, we understand. Which a chair. What's a man can come on April? Okay, distributive property. Sharing, distribute. Yeah. But I mean, try last week I said if this thing will cooperate. Then just writing with the yeah, difficult. Right, independent word. I don't know what has changed. It's so weird. This thing used to work fine. The previous times we have met, it worked really well. And today it's like, okay. But I'm going to come on today.
I'm going to view her. Yeah, no, a crabby could you more. Oh, Mamma poor friend, in a chinium. A crabby one.
Not like it.
So,
should I yeah. Okay, into the last into can saying I wanted to write I guess the synonyms, right? From what we have discussed, So okay, maybe. Okay, so I'll just say it. So fancy. Well, this is what we need to know. We talk about commutative. We are looking at basically migrating, moving variables around. We talk about associative. we are looking at grouping. So when you talk about additive identity property, we are adding to 0. We talk about additive inverse, we are adding the inverse of the number, which is the negative. You negate the number. Multiplication identity, you multiply by 1. Multiplicative inverse, you multiply by 1 over the number. Okay, and that always the answer is 1. Or distributive. The distributive, basically you have an expression like this: A parenthesis B plus C. So using this property, you have to share A to the variables inside the parenthesis. Okay, I know we've been doing this. I mean, your math, I'm sure you have done this many times. The reason we do it this way is because of this property. This property states that when you're multiplying a number by, you multiply in an expression, you have a number multiplying some variables inside in a parenthesis, right? You have to share that number to the variables in the parenthesis, and then you can go ahead and add them up. Okay, so this is possible because of the distributive property. Okay, so now this is that. Let's move on. Remember, questions be you can some just the answers. No, they're just mathematical expressions and their solutions, or a different way of writing them. And then they will ask you if they will ask you to indicate the kind of property that was used, to simplify that expression or rewrite that expression. Okay. All right. So the next one, first integer exponent scientific notation in order of operation. And I'm saying we'll be the last review, and then we'll actually go, start talking about algebra proper. Then we'll be solving algebra problems. So now, so Adam, so photocopy the materials be GMAT materials be.
GRE.
Or GRE. Okay, the same thing. You can still use. Okay, so where's the same? Sure, so why? So we are starting with exponent. Any number. So do you know any number? For example, if you have something like let's say 5. Yeah, I said it. Okay. Alright, so example, if you have this expression. Okay. Oh, wow. Let's say, so if you have something like 10 to the power minus 1, so in what way can you convert 10 to the power minus 1 into fraction? You can write it in a fraction form. What would that be?
1 out of 10.
Exactly, 1 over 10. So yeah, so you know this already. So a exponent minus m is basically going to be 1 over, yeah, okay, so what would this be? Actually, let me ask you. A to the power minus m, if you write it in fraction, what would that be? Person.
M out of A. M over A.
Oh, m over a. Okay. Now since we know, yeah, and so any number, this expression or a, yeah, so a over a to the power minus m, is going to be 1. That is 1. So always remember it is 1. 1 over the number. So this will be, this will be 1 over, it will be 1 over a to the power m. So 1 over a to the power m. So what I say, into 1 over that number. So okay, say 1 and about the top. 1 will be the what do you call the denominator. And then the number itself, becomes the denominator in a fraction form. Okay. Yeah, into way answer by the reason no say yeah, you might find let's say pencil no.
Pencil.
Pencil no. Yes, if you pay no paper they are easy to erase. Okay. Yeah, auntie, we by 1 over a to the power m. Yeah. And any number to the power 0 is also you're saying.
1.
1, yes. Any number to power 0 is 1. But the trick in here way, Nti bema we now the man assignment of the man memo examples and I say some questions be a over converted. But I think I went to him for
I made I black.
that's it.
My screen now black.
Because
Talk to Mozilla.
it's more screen so
The guy black. Lina.
good. Who used to Firefox and I said Chrome, Google Chrome.
Firefox.
But maybe who okay my bad. I mean stop sharing, I mean Who me?
I'm still filming I say because maybe a new application but black.
Oh. Yeah, I'm said before because me who so me who fine to camera na year dwuma.
Come on, the man who says Mama inclusion na me try.
Okay. Yeah, but after we na we then I'll scan it yeah. About okay. Okay, my man. Yeah, me share is screen of so okay, me share screen.
Um,
Okay. Yeah, this just the last section. If we are in one, then I'll scan the questions for you. Hopefully, after this, then we'll review. We actually get into some algebra, some actual algebra, polynomials. Okay. All right. So yeah. So any number to the, but I need to give examples of this one because when baby I tricky to try. Me to try and cover. More examples on that one. Okay. For example, so between me a throw. Yeah, 8 So 8 times 8 to the power minus 1. 8 times 8 to the power minus 1. Now, see if you can work that out and see what you get.
1.
1 exactly. What about 5 times 2 to the power 2? 5 times 2 to the power 2.
20.
Yeah, sure. What expanding is saying? What expanding when you're saying when you have 5 times what over what?
2 raised to the power 4.
No, but the question, no, ultra question here, then I will try the actual question is
5 times 2 raised to the power 2.
Oh, I'm sorry. 5 times 2 raised to the power minus 2.
Where 5 out of 4.
Okay, yeah, that's correct. 5 over 4. All right. Until I think one, and that's basically that's the concept that I want you to grasp. Okay, you see, so that is it. So that's for that, and this is one, always one. That's easy one. And also product rule. You name say, who name a to the power m times a to the power n. If you multiply any number, if the base is the same, the base is equal, then you can add the exponent. So we name that. And I remember many example.
Wait me an example.
Well, but we name na me have my home.
Yeah,
It's so fine. And then so if it is multiplication, you add them. If it is division, you subtract. So and of course division, they will always say a is not equal to 0 because you can't divide any number by 0. And then in this form, a to the power any number, and then the entire number raised to another number, you multiply the exponent. So a to the power m, and then the solution, the product of that number raised to another number is multiplication of these two numbers. So it will be m times n. AB is a to the power m, b to the power m. When you have two variables that are raised to the power a certain number, you raise both numbers to the power. A over b to the power m, say similar thing. A to the power m, b to the power m, and b, the denominator should not be equal to 0. Okay, so another way of Hanamon. Yeah, these are all your things that you already know. Okay. Okay. Yeah, so I was looking at examples. Intuiting what's okay. Young fancy how I mean scan it.
Come back to the other way. I try you. I can't last as you never try. May I capture me?
System ni more.
Come back and I'm completely back.
Never. We now open. Okay. We need me by my main. Sure. What's the best way to do this? Okay, what are my scanning questions? No, my scanning amount. Now, I just review. Okay, long because when I wouldn't know that. But review, will just kind of refresh your memory from them. Next time, if I'll me prepare the best start it, with full algebra, solving algebraic expressions. So then some of these concepts now you're reviewing, we'll start using them. And once we, I guess we progress a little bit with algebra, then we'll start looking at some of the actual exams questions. So I think that this basis, I mean, I think so. You're okay. You're good with the basics because the only idea I had, yeah. Okay. Yeah. Okay, I'll just spend this time. What's it?
I say you're better naturally.
And you're naturally, yeah. You're naturally. Yeah. Today, yeah. Until bye.
For the course of the week, yeah. If you're weak, I better than but we have free name. If you're bound like now, if we are between that was yeah.
So we free or light, yeah. By me, then find it out. Say, meeting a share. Why? Okay. Now, anyway, okay. Yeah, until the tray. I may close away.
Okay.
Okay, bye.